Hello, everybody. I'm going to try my best here. I got a pretty loud voice to begin with, as Cheryl may know, so I probably don't need the microphone, but I'll try making it so the people listening online don't have any broken speakers. So today, I'm going to be presenting some of our experiences at Valet in using Ventsim to achieve the life of mine plans that we issue every year. And maybe a little bit different than a lot of the presentations that have been going on, but it's not a very technical presentation. And it's more of just a recount of our experiences with it, and kind of what we like about it. And it's what I've been finding pretty interesting throughout this entire conference. This is my first time here. Is that there's a lot of similar themes that happen between each of the presentations, and in one of my slides, I'll even make reference to maybe some visual aids that have been used and some of the geometries of those visual aids that interest me a little bit. But let's get the show on the road. So show of hands, just to do this quickly, how many people here are students? Students? Well, there's a mature student. EITs? Couple EITs. I guess, mining engineers or technicians or people working in supervisory roles on site. All right, consultants. Okay, just gauging the room a little bit. If you didn't raise your hand up yet, you're in the wrong room. That's probably why you're confused. You're supposed to be in room 521. So I'm Stefano, Girardo, and I've worked for Valet for just coming up on a year now. And I wouldn't consider myself an expert Ventsim user. I wouldn't consider myself a subject matter expert in any of this really, but I work with a group of people that are, and it's been a pretty good time. I think that I'm a relatively experienced user in using Ventsim just because I've been using it since 2017, but I would say that kind of my recent employment with Valet is kind of taking it to the next stage and diving into some of the features. So again, this presentation will not reveal anything that's revolutionary within the industry, but is going to be a recount of how we use it. The general statement is I do enjoy using Ventsim, and it really has helped us use it. And again, quite a few people said this, and I'm glad other people feel the same way, as a communication tool. And it might be different, in all the walks of life that we are here, but I think that using it as a communication tool, it helps us bring everybody onto the same page. And something that I'll repeat a couple times is we need to communicate and understand the plan. The plan being the life of mine plan or the priorities of the organization. Quick summary of your agenda. Summary of 2 mines in which we're currently using this process that we started using. Kind of the actual process, how we kind of define stages, and the benefits that we've seen for Ventsim staging. Some of their mines. Unfortunately, the person who worked on this mine wasn't able to make it to this conference, so I'll go over it briefly, but this is one of our projects located in Thompson, Manitoba. You guys could probably do the math on which one it is if you read it hard enough. It's pretty complex. Vent system, kind of maturing, mine 60, 70 years old. As you see here, strike length of 6 kilometers and expanding to a depth of 1.7, hopefully. In this case, a lot of works were done to, or are currently in the process of simplifying the circuit and staging. I believe for this one here, we had 18 stages or 22 stages that subdivide each of these kind of major ventilation milestones. And as a result of kind of looking into it, working with the site, working with the central group, there's been a lot of investment in this. They're sinking what I believe was reported as the longest single raise bore in North America. And 2 of them, I share correct, so they're twinning, it's twinned. And underground, there's several booster stations with quite large horsepower. I think probably John worked on it as well with our team. No, okay. But it's a lot of investment, and I guess what I'm trying to drive here is that investment wouldn't take part, obviously without the technical and economic validation, but if people didn't understand what those stages are. Another mine, this one I did work on personally. is a mine in Sudbury, Ontario. So this one here is a much more simplistic layout. Looks like the dimensions are kind of cut off on the screen there, but they currently go down to about 4,700 feet and potential to expand to 5,600 feet. In this case here, the biggest difference and the reason why I've had these boxes on the diagram is that it's no longer just mining that main mine. It's breaking up. There's multiple zones that have to be ventilated. And it's important to have staging in these cases because when you start redirecting flow for flow-through ventilation to these separate zones is that you end up using more air or the activity in order to maintain the same production level. It stresses the system even more. So life of mine process. So I'll point out the geometry on this one. I didn't plan on really talking about this, but it's a line, if you haven't noticed. Step 1, step 2, step 3, step 4, all the way to 7. And it doesn't, I'll read them through, but none of them really show any problems. It's an idealized kind of timeline from step 1 all the way to step 7. If we were to pretend we started on January 1st, we have about 4 months to complete all of this. Now, we're not necessarily building the mine models from scratch. However, if there's, as the step 2 says there, if we are provided any information from mine planning based off of, drilling, new things have been moved to reserves, et cetera, we have to do a lot more to the model in order to prep it and kind of support it with potentially new infrastructure. So that's stage 1, stage 2. Stage 3, once we have this model, we have to assess it and compare it kind of to the short range, mid-range to long range and identify any risks that may exist in it. This is also a chance for communications to see if there was any zones or shortcomings in the year prior to see if the current kind of methodology of air determination needs to be revalidated. Stage 4, preliminary staging, determined off the proposed production profile. What infrastructure, so effectively what infrastructure is required? Is there new zones coming online? Do we have planned infrastructure that previously wasn't inside these life of mine plans? Number 5, essentially document it all, and from the ventilation standpoint, make justification for its reasoning. So will there be production losses, or is there opportunities to grow zones? Stage 6, so finalize it and kind of send it off for continued study. And 7, it's kind of accepted in its totality. And I pose a question here, and I feel like this is probably a question that a lot of us are challenged with when working on site, is should the schedule match the availability of flows, or should the availability of flows match the schedule? And this is kind of this non-linear, that's why I said linear before, it's kind of this non-linear concept, and I love it that we kind of worked on our presentation separately here at Valet, but all of our presentations had linear aspects and circular aspects, and a lot of these presentations had this concept of an iterative cycle. And so that's why I made the second diagram, again, very simplified compared to what actually goes on, I guess, with the internal studies and internal conversations. But on the, I guess it would be right side. Right side screen, the 4 boxes to the right, starting from stage 1 to stage 7, are if everything goes right. So if we receive the new mine plan and there's no issues, it's basically identical to the last year's, and there's less works and evaluations that have to be done, and so it can be quickly reviewed, agreed upon, finalized, and sent out. Now, what happens if it isn't? Which is more than not. There's always changes happening to the mine plan that are sparked again. Are the reserves or resources brought in or out? Has certain capital projects been budgeted and accepted? As well as even something kind of more recently that we've all been impacted by is regulatory changes, which is also a very important concept that has to be adhered to. So here, I just like to point out the one loop that I intentionally gave to it, is that if you follow stage 2 down to stage 3, there's a mid-range to long-range compatibility reviewed for the technical validity as well as the economic. And so can it support the plan? No. So then modeling and staging has to occur. And this modeling and staging, it's typically broken into two of what will the impacts be if there are no changes to the system and we work with what we have. And ultimately, to adhere to the plan, infrastructure changes might have to occur. And in that case, a model would be made reflectively. So this loop here is dangerous. And this loop here is what takes the majority of the time in this 4-month process every single year, because it has to be understood, and back to the previous question of what has to change. And it's in this kind of cycle of modeling and the importance of using Ventsim that we're able to quantify things. So before I said we need to communicate and understand the plan. So to communicate the plan, visual aids are good, right? But to understand the plan, to quantify losses, to quantify opportunity, that's what that loop is able to provide, not only to the ventilation team, but to the mine planning team and beyond. So staging creation, I'm a little bit upset about myself that I didn't do better slides on this. But this takes many shapes. And I asked a question during a previous presentation on how another operation does it. But in its most simplest form, what has to be understood is, previous quote-unquote ventilation milestones and production profiles or development profiles. And, when certain infrastructure is going to come online. And all of those milestones make up individual stages or individual changes. So what I've included here is just a tonnage profile. And so in its simplest form, here's your development and production tons multiplied by a constant. Here's a ballparked value for ventilation needs. But what an evaluation like that doesn't encompass is the fact, like I said before, that you could be splitting into multiple zones. And so while these kind of generalized numbers can be used in more of a greenfield concept, when you're making a life of plan or staging, we like to be a little bit more accurate or involved. And the way we've done that, we use DESWIC at Valet, and what we do is we assign air values to those specific tasks. And that could be done either on an equipment level, or it could be done in a generalized, development is to occur in this heading. And by doing that, we're able to get higher resolution either on a yearly, monthly, and if you're brave enough, daily Excel export. And it's something that can be updated and looked at not only by the ventilation group, but mine planning as they are actually developing the schedule. And every single time they make a change to it. Tying it back into Ventsim, if there's preliminary staging which already exists, then that means that, in stage 2, X amount of flow will be available in zone A, and the schedule will be able to be subdivided and report to what the requirements are. So the simplest way of determining it, as previously said, infrastructure upgrades and increased activity within a zone, which is something that has to be looked into further. So once you get how much air you need, and you already know because of you're using Ventsim and Ventsim staging for how much air you have, you can simply just, what's the delta? And in looking at this delta, again, this is something that mine planning can provide themselves as an evaluation tool of their own schedule for feasibility, is whether or not you're in the green or in your red. It's as simple as that. And, I think, a lot of the time, when we are looking at charts like this, our eyes are automatically driven to look at the red. And yes, the red most definitely has to be addressed. But I think what's kind of forgotten a little bit is that it's not all doom and gloom. Is that there's a lot of opportunity when you see things in the positive. Can that air be put somewhere else? Is that air used exclusively for infrastructure options? And in being able to see this over the life of mine, and in a relatively short amount of time and a short amount of effort to develop these kind of schedules, it's a lot of aid in making everyone understand the plan or understand the implications of the plan. And I put a little note here, and I'm sure everyone does their assessments differently, but I said assessments should be done by zone and ventilation ventilation circuit to locally determine flow variance and better account for leakage and auto compression. In previous studies, simply looking for what's on surface and applying kind of fudge factors and applying what the auto compression will be, or even using kind of averaged mass flows or volumetric flows, I think you can lose a lot of that detail. So if you do have a ventilation model that is calibrated and is reflective of that, by actually grabbing those values, and funny enough, I really like that it was shown the staging graph that you can select an airway and simply have all the data in one shot. You don't even have to switch between all of your stages. So wrapping it up, again, I guess you can tell I speak pretty positively about the software and about the process, but there's some generalized benefits we've seen to using the software. And I'd say record keeping. These are the ones, funny enough, like I was able to prepare these ones in a very short time, because these are really the ones that jump out to me right away is record keeping, communication, as I've already said, scenario modeling, and kind of risk and opportunity. I've covered most of these already. I believe 32 stages is what you can have in most of our mines. When we're doing our life of mine schedule for long range, not necessarily mid or short, we break it up into those larger ones. So there might be 3, 4, 5 years between stages. So most of our models don't have 32. Some maybe with scenario modeling is getting up there, but it's great. You don't need to have multiple files running, and it makes the kind of management of a master file a lot easier. Communication, again, communicate and understand the plan. Communication, I think, is most successful at one of our mines in Thompson, Manitoba, just in how well the projects group with the operations, as in the actual miners, and with the mine technical services team, understand those stages. And I say that's probably applicable elsewhere as well, even in terms of report documentation. Scenario modeling, first and foremost, Ventsim is a design software. So, it's a modeling software, so it should be used accordingly. And, we've used it in several applications. So we've used it to select boosters or size boosters, evaluate various arrangements for blast clearing, which was a larger study, especially when we're doing changeovers. Project work at rest conditions for increased fleet sizes. So, Sudbury, all of our mines are going down and out. So, we have increased considerations for things like that, of work rest due to temperatures, and optimize multi-leg raise arrangements, and, even do studies in terms of what is the cumulative pressure loss through, multiple legs. And ultimately, this whole presentation is to achieve life of mine plans. And risk and opportunity. I said it before. It's not all doom and gloom. I think whenever we're looking at life of mine plans, we have to be well aware of the risks, and most more often than not address those first. But there is opportunity, and I think that depending on how you assess the flows and assess your production profile, that it's a chance to gain more production. So that's about it for me. Pretty short and sweet. Better designs for safer mines. I'm going to trademark that in the future. So if you're going to take it tonight. My contact information is there if you have any questions about our process. As some of you may already know, I'm more than glad to talk. And thanks for having me here.
Thank you for speaking today. So, as usual, questions, everyone? I think they might be falling asleep by now, actually. Yes, here we go.
Hi, Stefano. Thank you for the presentation. It was good to see that the approach that you use does not differ too much from the one that we've used as consultants in the past, and also in previous workplaces where I've been. But I would like to know, how big is the team at Sudbury that works on these ventilation life of mine exercises?
Well, I guess the question changes by the week. We recently went through a reorganization, but previously we had 3 people dealing with modeling the 7 properties across Canada. In one form or another, that's still kind of the pace of it all. But I guess officially that's being moved to more 2 people managing the 7 properties. But each site has ventilation specialists that deal with mid-range, short-range, and soon-to-be long-range. And we still have a very strong centralized group that overlooks guidance and kind of projects.
Thank you.
Thanks for the presentation. A question on the airflows. There was a graph there on KCFM for a whole mine. The challenge I've seen with volumetric flow rates is for very deep and hot or hot mines, the density changes drastically. And so there's no conservation of volume, there's conservation of mass. And so I know miners like to talk about KCFM, everyone feels comfortable, but assigning a volumetric flow to a task, and then there's so many of these tasks, and so we come out with a number. The question is, where is that KCFM at? Is that at surface density? Is it underground? And how do you deal with that? Ventsim, of course, takes care of that, but it's just a more broad question.
Yep, no, 100%, and that's kind of where this disclaimer note comes from. So for that there, because Ventsim has the capabilities of compressing the flow and accounting for that volumetric, well, I guess density change, right? When we're pulling values to report to specific zones, we're pulling them at the localized density. And that's why I put this statement here, because exactly what you've just said is that a lot of the times the graphs that are currently, well, when we do our life of mine reports, we present both of those graphs. Basically, what's the total mine capacity from surface, and that graph looks different than this because it will be at surface elevation. But again, the nice part about it, and that's why I encourage people to do it, is that ultimately, even if your mine has several fresh air raises that are feeding individual levels, you'll more than likely also have something feeding the ramp or some kind of other major system. So the flow should be taken at that point in the model, and that is what is extracted automatically and then compared to the mine planning one. So that density change is accounted for using this methodology.
Thanks, Stefano. I'll work on these lines for my next presentations. There you had at the start, so thanks for that. Just, I guess, a bit off topic, question there, but I mean, with respect to the new regulations there within Ontario, how did that affect your life of mine there from the previous years to what you're doing today?
Well, that's kind of an ongoing discussion even within the company. I think as of right now, work's being done from an environmental standpoint, and doing a lot of that testing, as well as kind of fleet management and not I shouldn't say management, documentation and having an understanding of the situation of each of our mines, because we're not just dealing with one property. As of right now, as of today, all of the evaluations are still working with the previous regulations of 100 CFM per brake horsepower. And for a lot of our mines too, and this is kind of it's not a circular conversation, but it's a good conversation. Is that again, with the depth of a lot of our mines, right? Is that I'll specifically call out Creighton mine just because of its extreme depth. Is that you're ventilating for heat. So you're ventilating, and even the new regulations, to me, the basis of is you're ventilating for environmental conditions. You're not necessarily using such an easy number such as 100 CFM per brake horsepower, but it is something that is being looked at for opportunities in the future.
Thank you.
Thank you. Any last question on this topic? No? All good? Thank you, Stefano.